Yeah, so everyone, welcome to the Driver Hardware and API Workshop. I'm Alex Duyck, it's Dave Ahern. Here. Basically, we're looking at the challenges supporting multiple software stacks, which will be presented by David. Multi-PF single device setups from, I believe, Jacob Keller and Jerry Pirco. Extensions to PHC APIs for the PTP timers, which will be presented by Maciek Maszinowski. DevLink extensions, QAPI and NAPI, which will be presented by Amrita Nembiar, and then firmware control, which will be presented by David. Oh, so, well, yeah, did you not turn it on? Oh.
All right. Okay, there we go. That's better. Yeah, I was saying I'm not sure 100% if Enrico was going to do the DevLink extensions. It seemed like there was some interest, but I'm not quite sure. If not, that gives more time for a lovely talk.
Did they send you any slides or anything for that?
No.
Okay.
No.
So we'd have to guess at it. And I think we already have some of that in for the Netlink. That was kind of partially covered the other day. So
yes. Well, for Jacob. Okay. Well, I guess we just get forward and there. All right. Hello, everyone. So I wanted to start first with the challenges of what it means for PCI devices to work across multiple software stacks. And since firmware control got so contentious, I decided maybe we split up my voice between others, so get a break from me. I guess just to kind of set some context and a stage on this, like if you go way back in time, devices tend to be single function and they tended to work with a single networking system. Right? And so whatever software subsystem that the device was working with, the stacks pretty much owned the PCI device. Driver was designed to work with it. Software stack had its own introspection tools, that kind of thing, right? But over the years, devices have gotten much, much more complex. And at this point, devices like the one that we're building can work across multiple software stacks all at the same time, right? So it's not like there's a Netdev mode where the device only talks to the Linux networking stack, or an IB mode where it's only talking to the IB stack. We can have multiple software stacks in use at any given time. And so the way to handle a multifunction device, the auxiliary bus is of auxiliary devices. And it really is a brilliant way to expose multiple capabilities of a device and have these smaller focused drivers, strictly on that single software substack, and not trying to go to wedge everything into one gigantic driver. So as a consequence of this, though, you've got hardware resources that are kind of distributed across multiple software stacks. So for example, someone could be using a socket API program, and the Netdev is going to create some hardware queues and At the same time, someone could spin up a Rocky app, and it's going to want to do the same thing. It's going to want to create a memory region, create some domains, create some hardware queues. And if you're trying to do an introspection of this, today's tooling basically says you would run the Netdev commands, IP, tool, etc., and you would only see its view of the world. Same thing with Rocky. If you wanted to see what was going on with the Rocky QP, you're limited to whatever Rocky commands existed. Take that even a step further with subfunctions, for example, you can get multiple layers going on. So PCI device has multiple subfunctions. Each have their own auxiliary bus. Each auxiliary bus has one of those auxiliary devices. So you're getting this really complicated layering, who's consuming what. Right? The one thing that's missing today is this holistic view of all hardware resources. Okay? So not by silo, not by the Netdev stack, not by the Rocky stack or IB or anything else that comes along. So what we want to do is to have something that works down at the PCI layer or at the core device layer or whatever domain you're trying to dump at, right? Really, it's about choices depending on the problem you're trying to debug, right? It's also, we want to get not just the software view of it, what was configured, how many channels does the Netdev have, how many keys have been created. We want to get to be able to pull the hardware view of it as well. See if some mistake was made with all this multiple overlapping resource use, right? One thing we have to acknowledge is that every device is different. So device-specific details will vary across vendors. New hardware is developed for reasons. We have to just acknowledge that. And this ability to standardize and limit what you can run through some standard APIs is going to be very limiting. It's going to be very frustrating when you're trying to debug problems, right? Vendors are trying to be more open. There are roadblocks. Staying out of tree, for example, until some feature or configuration is standardized, only hurting users. And then, like I said before, we really want to have the introspection filters be in some really different ways. So if you've got processes creating QPs, for example, maybe I want to see all the QP that single process is opening. Or if I've got a sub-function, I want to see the resources in use at that level. Conceptually, DevLink is the API for that, right? It's an API at the PCI layer. It's logical to use it across networking. To date, though, that DevLink has had a Netdev legacy focus, right? All code changes go through Netdev, means it goes through its maintainer's lens and view of the world. For crossing subsystems, that means adding support for other subsystem details, right? So Kuba, for example, and I wish he was here because I really wanted this to be a conversation. I wanted him to be able to participate in this. So Kuba's made no secret of his disdain for InfiniBand. So does that mean we have a conflict with respect to what constitutes a legitimate feature or change, right? And the next question is, are we ready to expand DevLink, RDMA, and IB concepts? Are we ready to start having DevLink understand what a memory region is, what a domain is, dumping out queue detail, not just it's a queue depth of 8192 and there's 12 channels, but a lot more details about where the queue sits in memory, and maybe even the hardware side of it. That ability to get all flow steering rules, not just those going through a Netdev, but any flow steering rules installed for the QPs, right? And then even beyond that, again, hardware is different, with different capabilities. How do we handle the vendor-specific functionality? So really at that, this is just kind of the setup, but what I was hoping to have is a discussion around this and not just me speaking from the pulpit or something. It really needs to be a discussion, because there's been a lot of discussion around firmware control and now DevLink is the answer, but is it really the answer? So that's kind of what I wanted to focus on this first set. So does anyone either in the room or online have any comments along these lines?
Well, I'll go ahead and kick things off here. So in terms of the overall concept, I think ultimately what it comes down to is we're looking at, we've had discussions in the past about trying to move queue pairs up to a first class citizen. There's nothing else. What we might look at is instead of making it an entity at the Netdev level, make it more of a manageable resource in and of itself. Because if you look at it, all a Netdev is just a static allocation of queues for the most part, and then some rules to direct traffic to them. I think to some extent, if we were to tear some of that apart and start to reorganize things a little bit, that's the thing, is ultimately, as you know, Netdev has become this big, oversized, bloated thing that's everything and anything. And it seems like what we might need to look at doing is starting to deconstruct it to the point where, like right now, the big issue is we have like PFs that are hidden from the system via these IPUs and such. They're really running the whole show, but then, oh, no, we've got PFs in the host too. And it's like, well, okay, we've created this ambiguous mess now. Where it's like, okay, is this entity really controlling things, or is it just forking it off to somebody else to go control it, who then has to fork it off to somebody else? I think if we could just try to deconstruct things and make things as visible as possible to the user for the resource assignment and such, we could probably look at, I don't know, I'm kind of thinking out loud here, because that's the problem, is to some extent, the big issue is going to be switch dev, I think, in terms of it's the main competition for how this gets handled right now. All flow steering rules are supposed to go through switch dev at this, so I could see that being an issue.
I guess I see switch dev as just another feature functionality in the kernel. It's just another set of APIs for in-kernel stuff to talk to the driver.
Well, right.
Talk to the hardware.
But that's the thing, is we tend to not like, recreating the same thing over and over and over again. And that's kind of, I think, going to be pushback on it. Okay, you already have switch dev. Why do you need yet another interface to control flow steering rule? ETH tool, and then we had switch dev and Flower and TC. Yeah. It's like, okay, now this will be, TC, ETH tool, switch dev. This will be like the fourth interface now to control flow steering rules for a device.
When you say another way to do flow steering for a device, the comment here was about dumping flow steering. Made no assumptions on how flow steering. So, for example, the way DevMem is doing it, having user space daemons, doesn't work for us. We're doing it all in line. Yeah. So when socket is open, then you're going to create a flow in the Rocky driver. It knows the APIs that the core driver is exposing, all those APIs to install the flow steering. So there is no user space command needed.
Well, right.
But we want to see those, right? To have user space, or to have some admin wants to be able to debug going on, you need to be able to dump.
Right, but that's the thing, is there's right now already 2 or 3 ways to get in and dump them depending on how you want to display them. This would be yet another way to get in and start looking at the rules. And so it's like, it's one of those things where we have to justify that versus the existing approach.
Yes. Keep talking if you have more. I'll look for another microphone. It was sitting next to me. You'll have to kick that on.
Is that on? Yep. You said about deconstructing it. So are these for upper ways of doing it going to remain, or simply going to implement it on the bits that are underneath? Are you actually adding a new interface, or are you just re-implementing the existing ones on top of some sort of common layer?
I don't know. In my mind, it'd be more of a refactor, where you would have to do a legacy to support the existing common layer and then just bring it down underneath it. Kind of like, like with the filing stuff, it's like, okay, we're adding new APIs and we're trying to separate away from the drivers. Okay, well, maybe we need to do something for queue management and such. Like I know with, for example, when I was implementing FBNIC, I got the same pushback several other people have now from Kuba in terms of, okay, no, you need to change channels. You need to not tear anything down until you've allocated all the memory first. And so it's one of those things where it's like, okay, you have to kind of change the mindset for the implementation, because a lot of drivers, you'll look back to the old days, it's like, okay, I have to allocate 8 queues. KC alloc size times 8, done, 1 block of queues. Okay, yeah, you can't change anything after that. So it requires a little bit of re-architecture for maybe some of the older stuff to support something.
But I think the primary argument I'm making is that it doesn't belong in Netdev.
Well, right.
We're going, it really needs to be code at like a PCI level.
Well, yeah, but
where you're doing the introspection, whether it's a GenL or an IOCTL
right.
or something else.
But what it comes down to is basically it's just people having to change the mindset in terms of implementation.
Yeah.
That's the thing, is in my mind, I'm still thinking back to 2 or 3 years ago where it's okay, queues is first class citizens, you allocate a NetDev, but that's like a thin shim that then points off to all this linked list of queues that are, a resource in and of themselves.
We've been pushing back on reallocating queues for a lot more than 2 years.
Oh, I know. But it's just this, well, okay, I've been at this for too long. Yeah. So, like, to give you an idea, when I started working, I was working on like E1000E and IGB. So when I think back, it's like, okay, yeah.
Your one slide is capturing several questions, several areas.
Yeah.
So I think it's hard to find a single answer, probably. I'm still new. I want to touch on your last point of, are we ready to expand DevLink for RDMA? Comments are you're aware there is a tool called RDMA tool as part of IP Route 2.
Yep.
And that today exposes quite a lot of information of all the RDMA objects, being memory region, protection domain, queue pairs. It also, compared to Netdev, RDMA is a different beast where there are
Right.
100,000 queues and memory regions are existing. It can link to the process ID, shows quite a lot more details than typical channel infrastructure. So is that the right tool, or I'm not following the question? Do we want to take it out of RDMA and put it in DevLink, or?
Well, so I have looked at the RDMA tool, and it's very limited in the data that you pull out. If I wanted to know how many memory regions I have and you need the details of that, if you run the RDMA command, it'll tell you how many CQs are created or how many QPs. I want to know the details about them. Where are they in memory? How big are they?
Yes, you can. You can dump. So there are two commands: RDMA resource that dumps a list of resources, and then there is a detailed view where say, I want to dump this memory region. Show me what's this virtual address, its length, and protection rights, and so on.
And so that's going to be again limited to the RDMA stack, the IB stack view of the world. Kind of like the same problem with eTool, with IP and those commands. They understand the Netdev view of the world. I want a view of all of them. Because there's going to be other components coming along, other software stacks coming along. And, like even user space stacks, if they're doing something at the same time and you're trying to debug a problem, you want the holistic view at the device and not the siloed version. So that's the main question I'm asking is bringing in admin tool at the PCI device layer is independent of a software stack.
It's hard to consolidate all various different types of information in one, but
well, I think it'd be some level of abstraction that would be needed, and I could see it actually. It occurs to me that thinking about this, based on our conversation we were having earlier, it's like okay, both the busy pulling solution we saw yesterday, as well as the DevMem with the IOU ring, they're having to do some semantics to allocate queues, and then say, okay, traffic for this specific task goes to this one queue in order to get what they need. And if we had something more like a queue pair approach, where it's like, okay, create this socket and allocate it a queue pair automatically, that could then, right.
So you're making assumptions about what create QP means.
Well, it depends.
Not all devices have to create them the same.
Well, right. But that's the thing. To some extent, it's a resource that has to be split off. And in this case, it's one specific application is using it. Traffic for that one specific application gets routed to it. Mm-hmm. And then for the IOU ring, it has to use one specific block of memory in order to be able to function.
Guys, please raise your hand. We'll give you the mic. There's quite a few remote people who want to hear this.
Okay. We should, just from a time perspective, maybe cut it off in like another 5 minutes.
So I have a proposal for you. I don't know if people will accept it or not, but the idea here is something that Jake and I talked about a while ago. There's actually a piece missing functionality in the idea of maintaining a driver for a PCI dev. So it goes nicely with your PCI device layer idea, right? So today our network device
firmware control device.
Well, yeah, I mean our network device drivers grab PCI device. Right? Mm-hmm. We actually have our network device drivers do multiple subsystems. I don't know if most people realize that, right? They do a whole bunch of different entry points, and we have to manage all.
So it's not just that they can work with InfiniBand, or they can work with. It's about everything coexisting at the same time. You've got multiple use cases in flight at the same time.
I agree. So what I'm proposing here is something that attaches a driver set that attaches at that PCI layer and understands that it's working with a device that is, or it's a driver for the general hardware device, right? That can act more like a control plane driver. Yeah. If you want to think about it that way, it's more understanding just the device, and it would give us the ability to maybe run and have debug places. Now, we don't know what the user interface looks like, but the idea is not there in the kernel right now. There isn't really.
So hold that thought for the firmware control discussion later.
Yeah. Is that the FWCTL? Yeah. So, but yeah, the thought there is does that device driver layer, this new set of device drivers that sort of actually have to cooperate maybe with other device drivers a little bit. I don't know. But
I'm still thinking if this, maybe I've got a mental block here, that the PCI device interaction for the admin tool, because you don't care about individual stacks. So you shouldn't be interacting with multiple other virtual devices like that. So I guess let's do Andrew one more time, and then Jamal said someone online was asking questions.
I would say it does actually exist. You just need to take your Netdev blinkers off and look at MFD, multifunction devices. Extend that concept. PCI.
Jamal, was there someone online who had a question? Oh, okay. But we don't know of any questions coming in online.
Can you guys hear me? This is John.
Yeah, we can hear you.
Yep.
Oh, cool. The only comment I had was like, it seems to me like there's like a fundamental question of if DevLink is a networking device link or a proper PCI configuration device link. And if you can't get an answer to that, I wonder if we'll just go in circles, right? Because if half of us think it's a device link for all devices, and we're trying to put in configuration for InfiniBand and RDMA and DPUs and whatever else kind of devices we're going to start attaching to the PCI bus. And then the other half of us think like only networking things are allowed in DevLink. It just like, it seems so fundamental, right? That was my comment. I don't have a good answer. I was pointing that out.
So one thing I've noticed is working with DevLink and F-Tool in general is when I need to automate things, like I'm working on a lot of testing, DevLink, you're shelling out to. You have to auth and grep and do all this stuff to get data out of it. So whatever tool we land on and either extend or create, I do think we need better APIs where you can output in machine meter readable format, have Python, Rust APIs. So you're not just like shelling out and grepping and doing all these things that are like kind of weak and could break very easily.
You're next anyway. Sorry, I was just telling Jacob to come on up because he's next anyway.
To answer that, you can write Netlink and write it in any language you want with a lot of the bindings. So you don't have to use the DevLink shell output. You can write C code or Python or other languages have bindings and get it in the format that would be useful for you. That would probably be a lot better for your use cases, depending on what languages you're writing in. For simple one-off stuff, shell scripting is fast. Start doing something that needs to be automated or long-term. The actual interface to the kernel and user space is Netlink based for DevLink. So it's generic Netlink.
Okay. We'll look at that thing.
Jacob. All right. If any other questions, we can find a BOF later, or we'll see if we have any extra time based on content. Do you have slides you want to?
I don't have slides.
Okay.
I'm mostly more of a questions and discussion. So I work mostly on ICE drivers. I'm Jake. We've been working on the ICE 100 gig driver, and we've been having issues with precision time protocol, where we have these PCI devices. They're multi-function, right? So each function shows up as a PCI device. If it's a 4-port, we end up getting 4 ports, and each one of those loads a PCI driver. That PCI driver does all the Netdev stuff, all of whatever. And we have issues because with PTP, there's one clock. It's shared across all the devices. Only one of the functions is supposed to control the clock. There's a lot of interactions where things happen across these functions. And we implemented a hack sort of solution using auxiliary bus where the function that owns the clock would register an auxiliary driver, and all of the functions that want to talk to that clock would register auxiliary devices. But the problem is auxiliary bus is meant for like inter-driver communication where the driver doesn't care what device it's talking to. And in this case, only the functions that are on the same adapter or the same physical device need to be connected. And so we implemented it with it like building the names of the auxiliary bus and putting it together, and it works, but it kind of broke the way auxiliary bus is supposed to work. And we merged it, and then it got told, please pull it out, remove it. And then it's like, okay, but what do we replace it with? What do you do when you have multiple functions that are all really one device, but not really one device, kind of? And I've seen some stuff that's there, but
obvious, but did you try the common clock framework?
The ones we found were, I looked at like the multifunction device MFD stuff.
No.
Okay.
Well, system on chips, got clocks everywhere, and you need to control them from multiple devices. It's called the common clock framework. Russell King, 25 years ago. See if that helps you at all. Another thing, everybody seems to be stuck Netdev linkers. Get out of it.
Yeah.
Turn up. There's lots of infrastructure everywhere you can try and reuse. Common clock framework might solve the problem. It might not, but it's something to look at.
The other thing to note is this problem is somewhat more general. We've had specific cases where we have PTP has this problem, but there are other cases like device-wide resources for RSS or flow steering or different queue resources where we have all these things where all of these PFs want to be able to share them somehow. And the thought I had kind of piggybacks on what Jesse said earlier was some sort of like device layering where you'd load one driver that's like the device driver for the whole device, and then you'd load the same function driver that's the function driver, and they would automatically get connected somehow. Yeah.
It would really help if people looked at system on chips a lot more, because these are all solved problems from that perspective. So don't think about Netdev, think about Linux. Go look at how SPI buses are shared, how MGI buses are shared, how memory devices are shared. It's probably a solved problem. You're just not looking at a big enough picture.
Which is exactly why I wanted to ask some of these questions. Is sometimes I've searched for things, but it can be hard to find the actual place to look or the names to look for.
There's one caveat to that, though. The problem is direct device assignment, if I'm not mistaken, implies you cannot expect software to solve this problem.
Sort of. Sometimes you can just live with, we won't direct assign like that because you have to live with some limitations. Part of this is the device design, right? Is if the device decided it's multifunction, but it's not really independent. That's, but we can't change the existing device, right?
Yeah, so it comes to the common clock APIs. They are designed to physical clocks, like not the timers that we built on top of it. So that is not probably solving it as far as I recall. But the problem here is much broader because if you have a multi-PF device, then the device may be shared between different hosts. And then you can't just use infrastructure only in the kernel. You need to go outside it.
How do we expect PTM to work with a multi-PF? Or it's a different?
PTM, I would expect if the device works right, each function that either you have one clock and then the clock would issue the PTM, like in our case, PTPI info structure has a cross timestamp function and it would then initiate a PTM transaction and everybody should be going through that same clock. If you have like multi-host, device hopefully would support each host being able to do that. That does create problems because like in the hardware we have, all the PFs can do it, but then there's like this hardware semaphore you have to acquire, wait for it. There's all these timeout rules and it gets really complicated. And a lot of that comes down to how well the device can handle the multi-host and the multiple cases. But this is where the challenge is. If you're all in one host, we can do some of these software solutions, and that would significantly benefit in the case where we do only have one host and we're not doing assignment of those functions PMs.
So it's one host, 2 PS.
Yeah, in our case, it's one host. It's 2, 4, or possibly 8 PS.
Yeah, more than one.
Yeah.
In that case, do we expose multiple clocks or just one clock?
In the ICE driver, we expose one clock. On the older drivers like I40E or IXGBE, every clock had different registers. Every port had different registers, so every port was effectively a different clock. So we expose different clocks, which avoids the problem because now they all have their own clock. They're kind of independent. But in the ICE case, there's only one set of registers that all the PS can see. But if you have 2 PS go and write that register, it's going to cause problems, which is where we end up in this case where the software wasn't really aware of it. It was colliding with each other, and then we put firmware-ish locks in place, but they were kind of late designed. It wasn't built in, and it became a mess, and the firmware solutions were too slow. We have problems where talking to firmware, it's never designed to give you really low latency access. It's run to complete, so it's always going to be blocked while you're waiting for it to complete. Sometimes it's fine and it takes it within your time limit. Other times it suddenly spikes to 100 times your time limit and no one knows what happened.
Don't we need to build a framework that allows one clock per PF, where current Netdev is you enable PTP or others as a Netdev, but in the model of yours, there are 2 PFs, 1 Netdev, 2 clocks.
Yeah, in our model, we have 2 PFs, 2 NetDevs, 1 clock, and both NetDevs have their link point to the same clock, and all the timestamp domains are the same clock. But then it mostly works because Linux PTP will come in, find the clock device, and they'll share the clock device, so it'll only have one place accessing the clock. But there are still issues with timestamping because the timestamps are in the hardware somewhere that's in a shared block, and they both have to get access, and it needs to come over only one PS. And we solved a lot of these problems with hacks that kind of work, but it feels like we're just slapping duct tape on the side till we fix the problem. And fundamentally, we're at this point where device model doesn't quite map to how the hardware works because multifunction, but they're not independent enough to be fully separate. And that's where I was looking for, these examples of looking at the clock or looking at multifunction are places I now know I can research that I failed to surface on my own Googling.
So for shared resources like a clock, I believe it makes more sense if we get one function to have write permission and all the others to get read permission. Have you considered that option?
That's effectively how it's supposed to work, right? But we're doing it with like bespoke interface right now where the clock owner, like the firmware tells us which PF is the clock owner. It's the one that comes up and it does all the write access and talks to it. But then all of the other PFs, originally in the initial code, the other PFs didn't really need to know about the clock device. So we just they just knew that the driver couldn't access those registers. But what ultimately started happening is we ran into corner cases where they suddenly do need to know about the clock and maybe communicate with it in some way, and figuring out the best interfaces for that. Like the auxiliary thing was what's the first thing we found that works? But again, it's a little bit of like blinders are on. We're only looking at the things we know about. And it's meant for this inner driver communication. You can segment your NetDev driver out into its own thing so that it doesn't have to be aware as much about all the, it's abstraction. But in our case, we didn't really abstract it. We just made it use the auxiliary bus as a way to get a link from one PF to the other. We are looking at replacing that, but trying to figure out what's the best way to solve that.
I mean, if we make the whole stack aware, including user space, like PTP Pro, if it has permission to read or write, like one instance can synchronize the clock.
Right. In this case, to user space, we only expose one PTP clock device. It's just that they're in the driver. There are places we didn't expect to have cross PF issues. like with timestamping, it was supposed to be each port could do its own timestamps and report them, and they all came from the clock domain, but there's still only one PTP clock in user space. But we ran into problems because it turns out that you can't have two PS doing the timestamping at the same time, because in the hardware, there are interactions that cross the PF, and if the two do things at the same time, they cause some weird problems. And so we had to do it in software because it was intended not to have that, but things crop up, things don't work the way that you thought they did when you designed them.
So here comes the configuration problem. How do you decide which PS gets to manage the clock?
In our case, it's firmware decides when it boots up, it anoints one as the owner, and you get a flag that tells you, right? So that kind of solves that problem there. But of course, it's firmware black box again. Yeah.
So I think there's a similar issue that was solved by Jakub, I think 4 years ago, maybe. Sharing for UDP tunnels, like the destination UDP ports. You kind of introduced a kernel mechanism to share the shared UDP table between multiple functions of a single device. Maybe we can take that kind of approach and use it for the clock.
Yeah, that could be interesting. I remember seeing some of that go in. I think a lot of it that was mostly tied in still at the networking layer where the Netdevs figured that out. I'd have to go figure out what mechanism was used to find the shared devices there. The solution we're kind of settling on for ICE right now, for a different bug, someone from Red Hat built this like ref counted adapter structure where each PF, when it loads, it goes to a driver's X array and creates an adapter structure, and it's tied to the bus function number. And it's going to work, but my worry is that it's like just hiding it all in the driver, so it'll solve our driver problems, but it feels like something the core device stack should be able to do for us. So I was hoping to find some places to look at where has this been solved before, because it doesn't seem like it's a new problem, and we're just not aware of what the solutions were.
Try the mailing list. I'm sure there's not many system on chip people here, but they are on the mailing list.
That's kind of all I really had for discussion. So.
One thing I'm seeing or hearing from you and obviously myself, people have a hard time finding these libraries and finding these tools, and Google isn't turning up what we need. So is the solution just better documentation on here are all the things you should be looking at? Because yeah, we could send out emails to the mailing list, but the person that knows this isn't available. And if we just have really good documentation, then we know the tool to use and where to start looking at least.
That definitely matches my experience of trying to Google some of this. Some of this is just not knowing the names of what to search for. Like if you're just doing text searches, it's hard to find the information. Obviously, I mean, we've had this thing a lot where the documentation's not great, is a common theme I've seen at this and other conferences before. So I know I try to document when
Better mailing list might be ARM SOC, where all the SOC people hang out, and they tend to know everything everywhere. Because system on chips is everything.
that should be helpful. Thank you. Any other questions or online? Thanks for the discussion.
Okay, so can you hear me well? Okay, so my proposal is about actually solving a bit of this problem or trying to tackle into it. So I wanted to present some improvements to the time uncertainty API or like to the PTP clock so that we can actually define some kind of time uncertainty. And I will need your help here to understand if my understanding of the problem is the same as yours. So that, I'm not trying to create something out of vacuum that will not be useful for your use cases. I know that many of like vendors do a lot in this space because I already found some prior work on that. So here's the list of couple papers, work, code that I was able to find about this problem. So there is a comprehensive spec about the precision time API created by Meta and NVIDIA, and it's like opened as a standard on the OCP, but it's a very comprehensive API for precision time that replaces a lot of regular calls with special calls that gives you the information about the uncertainty. So maybe let's do you know what clock uncertainty is all about, or should I maybe explain what it is all about? Because if you get a transaction, for example, in a database, you would like to know what's the uncertainty window. So what the earliest time and the latest time that this transaction may have happened. We need the window because the time is never like the precise because you always have some kind of error in the timing that results from your clock resolution, from the crystal oscillators not being perfect, or other problems on that path, different path delays or some asymmetries. Some things you may guess, some things you will need to somehow calculate. But in the end, what you need to know is what's the time window that this event definitely happened within. So that's what the uncertainty is all about. So this spec, as I mentioned before, is very comprehensive. It tries to define a very comprehensive API that doesn't really, in my head, belong to the kernel because it's far too complex. It tries to replace all the APIs that exist there today with the ones that will also return the window of uncertainty. So I think it's not the one that we should tackle because the kernel we will need to change too many subsystems, tackle into too many places, and it's probably too complex to start with. So another solution comes from Intel. It's a clock manager that tries to pull the information about the synchronization from the time sync daemon. So it uses the PMC protocol to understand the quality of the synchronization that from a running PTP4L instance, and then creates a library that gives you the window of uncertainty, but you still take the time from the system, which is probably the good way to. Another solution is what AWS deployed in their data center. So it's the AWS Nitro time sync.
So just a clarifying question. When you're talking about the bounds here, are you talking about a Gaussian distribution where you're making something about sigma choices, or are you really trying to define edge bounds in time, which you believe are hard, that everything has laid within this one?
Yeah, it's more about the edges. More about the like defining the period within the event definitely happened, not about the Gaussian distribution and trying
so you
to
want to know,
the best one.
You believe that it's definitely then between this upper and lower
between
bound.
the earliest 10 places, which is actually what they return in an AWS, because that's important for databases. For other use cases, maybe the Gaussian is also important because you may want to put a point in time, for example, for the logging that's trying to connect different systems. Then the Gaussian also makes sense. But that's probably something that we should push into a library that will do this. But we need to provide some primitives from the kernel driver so that actually something working on top of it can do something with it. So that's what it's all about, really. So this is what ENA driver does in their custom kernel out of tree implementation. So what they expose is a PHC error bound sysfs file that exposes the error bound and additional statistics about the errors of the PHC. But when I started to explore the kernel code, I actually found that there is a better place, better way of doing it, with which I will talk about a bit later. So non-goals, like I said, I'm not trying to solve all the problems. Libraries will still need to calculate whatever is patient specific. So if it's a database, still latest calculations should be done in some middle layer library. And I'm not trying to tackle the problem of understanding which PHC is a source of time, because that will also fall on the some upper layer libraries, for example, some daemons that already does time things like Ronnie or something. So a quick recap, this is the current API of the PTP clock info. So that's all the goodness we have so far. There is nothing that actually gives us any information about the error, unless we will take a look at the adjust time, adjust phase functions. So that's one thing that we will need to definitely tackle to improve it. So the missing APIs. Showing something different on my screen and on this. Anyways, so we don't have an API that gives us. It's okay. It's just like one click away. So I'll just look. So the missing APIs are about the last reported error. So we can't get the device to give us what was the last error it's been compared to the source that it's trying to synchronize this. Then we don't have the information about the state of the clock, whether it's actually synchronized to something or not. This something that somehow may help with your problem, because if the device sees that the clock is already synchronized, then it can just not try to synchronize it again. Obviously, it's a problem of trust and trying to give additional information about the clock that I will talk about it a bit in the like what we can do else, but that's not in the initial proposal. It won't be part of the initial proposal because there is no existing subsystem or existing piece that we can reuse to actually convey it, and we will need to develop something special to solve that problem. Another problem is the information about stability of the oscillator that is required for calculating the uncertainty window and may definitely improve it, because it will, once we know the time when the last correction happened and we know the boundaries of the oscillator stability, we can calculate the window of uncertainty for much longer time than just, for example, immediately after the error happened and was ready. So the stretch goals, the programmable static error, for example, the quantization error, it would be a good thing because we will be able to add it and accumulate it in the maximum error. The block of the clock read, so don't allow to read the clock whenever the clock is out of bounds, is something we may also think of, but it's also not part of the initial proposal. And also the data set of the grandmaster that the clock is synchronized to is also something that may help with building more trust about what your clock reports. But that's also something that needs more work because it actually requires passing quite a lot of data through the device, through the firmware, or through the interface that will actually somehow try to report that to the drivers. Yeah, and like I said, it's unfortunately there is now no place because I actually tried to fit all the first parts into the existing APIs for the POSIX clock. So the kernel timex structure actually has places for all of those, but no one really cared enough to implement them for the PTP subsystem. they are actually implemented in the NTP, but it never like was moved on to the PTP. Yeah, so like I said, the clock adjust time already operates on the timex structure. So basically we have a lot of, you're trying to pull enough. But as you can see, there are a lot of information that the structure can return. So for example, we have the clock precisions, we have the stability information. Some of them are not directly saying that it's something that that we need. So for example, we have the CPS frequency and not the oscillator stability, because with the only oscillator stability we have is tolerance, but it's in TPM, so it's not really enough for our use cases. So maybe we will just tackle into the CPS frequency and call that frequency of our synchronized clock. The other one is the maximum error. It's not really true that it's in microseconds, because there is a mode where you can change all the values to be reported in nanoseconds. This comment probably should be tweaked a bit to be more precise with what the structure does already. But all the current PTP clocks return is the frequency, which is the offset of the frequency that was registered by the clock. So I believe by just filling in that structure, we could address a lot of needs that actually end users will need. And I'm trying to understand from all of you that, you know, if it works, it would help your use cases and work in your scenarios. So there are two ways in which this API can work. So the first way is where the hardware would own the synchronization. So we can offload the whole synchronization, which is probably desired in many data centers, to the device, where you can have a smart NIC DPU that will actually synchronize the time, synchronize its own timer, and pass that up to your PS or VS or anywhere that it will expose the clock. And the other scenario is where the operation system would own this synchronization, but will also push the state of the synchronization to the device, so that device is also aware. So, for example, for the traffic spacing, scheduling, and all of those new features that we are trying to implement, the device will also be aware that there are some boundaries, and you will be able, for example, to pre-program the device so that it don't try to, for example, traffic shape on the clock when the clock gets off from the source, and this will help your data center not have some stragglers that tries to push the traffic whenever they should not. Okay, so couple like proposals. I don't know, like I'm open for discussion to make sure that this is what will suit the needs. So the get last error function that will be added to the PTP clock, which will read the last error and report it in the max error and estimated error inside the timex structure. So because we need the calls to the driver, so that the driver can actually fill in this information and not just statically somehow cache it in the PTP device, because that will cause more problems, because then we will not be able to upload the synchronization. The function get clock state is a bit problematic one, because unfortunately timex only supports one flag, which says the status unsync. So if it's set the clock was not synced, when it's cleared the clock is synchronized. We would probably want something that will give us more information. So I would say those three states is what probably we would like to have. So the unknown, which was never logged, your device just booted up and was never synchronized. Then the locked and the free running mode, when it was locked at one point of time, but it lost track of the reference. So this is something we would need to find maybe a better place. unfortunately, as far as I recall, those flags are out of bits, so it may not be possible to add more flags. I will take a closer look at what's possible. So the next one is the
Quick question about the last slide for get last error. Why do you propose pushing it to ETH-tool stats instead of DevLink Health Reporter?
The thing is, I'm trying to tackle into existing APIs for the clock so that you can easily pass that information then to your system clock, because ultimately, once you get this information from your PTP clock, you should pass them along to your system clock. Because in the end, if you want to get time, you should never rely on your device. That's what I was talking about yesterday. Because every get time from your NIC that sits on the PCI bus is always delayed by the PCIe transaction. So the timestamp of it is always delayed by microsecond or something like that. That's why you should synchronize your system clock. And then, if we use the generic timex structure, we will be able to just copy the information from one source to another. It's still a clock. It still returns the timex structure. So I would like to find a way that we can get the minimum set of information here, and then obviously grow it to ETH-tool, to DevLink, or to IO calls probably, because we don't support the DevLink in the PTP subsystem. And then maybe, grow it to give you more information whenever you desire, for example, the data set.
So actually, having a timestamp available in ETH-tool that makes a lot of sense.
Can you take your comment?
Yeah. So I'm saying that having a timestamp in ETH-tool that makes a lot of sense and very helpful for debug whenever you're trying to calculate like a For example, we many times pull stats 1 per second, try to calculate that. That's not accurate unless you have stamp inside the stat.
But you mean the hardware timestamp for packets reported in the ETH-tool, or?
No, the timestamp for when this log stats were collected.
Yeah, this is
the system clock.
Yeah. I'm trying to add the system handling of the system clock,
so this
whenever the device. Yeah.
Makes a lot of sense.
Yes, because that's also needed for calculating the window uncertainty when you lose track of your source.
Yeah.
So yes, but there is unfortunately no way to expose it to IMAX. But it can be cached in the PTP device clock, and then used for calculating, all the necessary information. But IMAX unfortunately cannot return it. But we can probably add more IO calls. But then, whenever you add IO calls, there's much more people looking at it, and it's usually much harder. So I'm trying to do a minimum viable product. Define something that will actually meet the needs, and once you put a foot in the door, then it will be easier, to say we also need this, so let's also try to do this and that.
Agreed. I guess to kind of keep this drumbeat going around mentioning of data and APIs, ETH-tool is a Netdev concept, but time is not a Netdev specific thing. So why continue adding something that works across, like someone doing IB traffic, UEC comes along, if Netdev, like all these things at once, time and time stats should really be independent of the Netdev tool.
Yeah, especially
the theme I've been going at.
That PTP subsystem also now supports time cards, which are completely separate bits. So probably growing the IO calls for PTP clocks is a way to go, because that's what they provide now.
It does seem like the IOCTL interface is a problem. What is the threshold to throw it away and swap to Netlink?
PTP clock does not support Netlink.
No, but that's when do you decide it's just dead, we can't extend it anymore?
Yeah, I'm not saying we can't extend it. It's more about once you start adding more IO calls, you get much more pushback and stuff like that.
When do you give up extending it and just swap to Netlink? At that time, maybe it is. It's going to be a couple-year project, but you'll avoid a lot.
Yeah, I understand your point of view, but on the other hand, it's a subsystem kind of detached from the Netdev, but kind of on the same mailing list. So, maybe, but don't want to start from, okay, here is the rework, good luck, review it, and, so I want to start with something small, that will help us, build more momentum and understanding whether it is the way to go or we should, maybe tweak it or something. Yeah, so then another function is the get stable, which will actually get the PPS stability or the stability of our clock. Those are the two fields, like there is a tolerance, but it's in ppm, as I said, and it's not enough for our needs. Especially once we move to better oscillators for telconics and stuff like that, they are definitely not in ppm. And there is a stable which we can maybe just reuse and assume that this is the okay place to return the stability of the clock and calculate on that in the PTP subsystem. And obviously we need the function that will set the clock state. There is plenty of flags that already exist. POSIX clocks adjust time function. So we can probably just piggyback on those flags and be able to easily push the information that is needed into the kernel. And those optional APIs, those are the ones that I don't have good idea where, probably will require some more work in defining new IO code. So a programmable baseline error, so the one that will be always added to whatever your device or your software reports, like quantization of your clock. So if your clock peaks at 2 nanosecond rate or 4 nanosecond rate, you know that you always should add this to the uncertainty.
Yeah. I expect Richard will just knock that straight out. He always says, don't try to do that in the kernel.
But do what?
Try to figure out what is the baseline error in the kernel.
Yeah, that's why okay, so yeah, that's exactly the feedback that I'm looking for. If that was tried somewhere, then let's maybe reconsider.
Been tried multiple times and hacked multiple times. So I think you're very unlikely to be able to succeed with that.
Yeah, that's why it's in the optional section that, maybe we will tackle it in the future. Another one is function that will return you the window of uncertainty, because we can calculate the maximum error as the last error plus the delta of the system time times the precision as a measure of the maximum error that's accumulated over the period of time that you from the last time you got the correction. And the block to read, like I said, you want to maybe block the read of clock whenever we cross a certain pre-programmed threshold. And obviously maybe some fast counters, something like that. And the last one is the info about the data set, but that's definitely something we need to leave for later. So once we get the stability information, we may try to figure out a way how can we get the data set of the clock. So every PTP grandmaster will introduce itself by the data set, which is passed in the PTP messages. So if we can expose that, we can build more trust around the clock and verify that it's actually synchronized to a source that we also trust in our application. Yeah, so just a summary, just a repeat of the structures we have. And thanks, that's all. And I'd be happy to learn whether if you would find this helpful and you would back it up on the mailing list if there is some pushback. And
I do think where possible, ending what we report through Timex is that, especially if it already has fields that we can use, is a pretty good low-hanging fruit level place to work. Obviously, a lot of this data is stuff that doesn't fit there, and you are right, it's quite complicated to move from the APIs we have, and if we have to extend the octals or change to something else, that's a much bigger task. So I do think focusing on, can we get some of this data out, even if we can't solve the whole problem, it still would be valuable to the user space side to get some of that data that's in the hardware but not visible.
mm-hmm. Anything else? Anyone online by chance? Follow you the online monitor? No? Okay. All right. Thank you. Okay, still unclear about Amrita, whether we're going to have the next discussion. I guess given that, the next topic. All right. I'm kind of curious. How many people up here in this room have heard about firmware control? All right. So people have a lot of spare time on their hands to read long threads. All right. Before I dive into it and talk about what firmware control is, I'd really just like to kind of set some context again and just kind of remind people like to think about where we are and how we got there. And the key to that is this is 2024, not 2004. Linux isn't some hobbyist OS that businesses are kind of contemplating about using, right? We really should keep in mind the openness of ideas and the acceptance of ideas that got Linux to the point that it is now. And specifically, Linux and its ecosystems thrive when we're optimistic about possibilities. When we're optimistic about what some capability provides to a user or even developers and how they're trying to manage and survive their jobs, right? And really, it's like everything has to evolve to survive, to maintain its relevance. And another one is Linux is about choices. People love NetFilter, people love TC, subsystems, different things, different choices, right? Really, developers should be focusing on building primitives, building these building blocks with well-defined APIs that allow people to assemble them in a way that they get to pick where they want to, what overhead is acceptable to them and what overhead is not. Right? So if people are okay with NetFilter overhead, go for it. We're okay with BPF, whatever it is, right? This is about choices. And whether we want to agree with this or not, like Linux is used by and driven by businesses, right? There's many established and entrenched camps. It's not going to change. There are people who love the socket API. Don't want to see anything else. There are people who love RDMA. Don't consider anything else. There are people who think the user space networking stacks, Linux is too heavyweight. I must do DPDK style frameworks or user space stacks to get the performance I need, right? Really not, we're not ever going to come to a consensus that those are bad. It's choices. People are choosing how they want to deploy a product. The other one is out of tree drivers. And, long history there. In so many ways, out of tree drivers are an established and forced that has to exist, right? The changes are for real use cases. You gotta check. Data-tree drivers, they're really trying to solve real use cases, real problems, right? And it's a proposal for an idea of how to do something. Maybe it's not quite ready for integration to main, or maybe it's because trying to integrate in the mainline is failing, but yet some customer really wants that feature. And the last one is that, hardware is different. Again, there's a lot of overlap with the first talk that I did in this section. Hardware vendors are not going to open source their firmware and device design. It's never going to happen. Different companies exist for different reasons. Devices have differences, and the software needs to acknowledge and deal with that. Another one is that there's a whole lot of kernel APIs. Those APIs enable varying degrees of bypass. So SysFS has been around for a long time. It gives you direct device access from UIO, VFIO. I'll let knowledgeable about those two, but again, it's other ways to use device and user space. The networking side, like I said, RDMA, OVS bypasses big parts of the stack. eBPF is all the rage, and it's basically bypassing certain of the stack and choosing what people want to do. The one I really wanted to talk about, to me, that kind of aligns with firmware control is AFXDP. AFXDP bypasses Linux networking for the data path. Okay? Packets do not traverse the stack at all. It was deemed acceptable by Netdev maintainers. Why? Because it uses networking APIs to some degree, the Netdev operations, setting up the control path and with some level of monitoring, basically, right? The heavy rationalization there is it's a step in the right direction. We're bringing in more standard code, more standard APIs, more standard ways of doing things, right? But AFXDP is a networking stack bypass solution. So what is firmware control? The new subsystem intended to bring some common rules and order, growing pattern of needing secure and direct access to firmware from user space. Focused on debugging, configuration, and provisioning. The fact that we have vendor-specific differences in how things are going to be done. Okay? What does a gyro timer mean in one piece of hardware is going to be completely different, have a different complete meaning for another piece of hardware. And also it allows to define and document the rules that a device must follow to expose something similar to the SysFS style RPC, but with a lockdown kernel. Okay. Really all of this came about with the lockdown kernel and NVIDIA, for example, driving this, looking for solutions to still be able to do the debugging that they needed. So again, the intent here is moving in the direction of common code to the extent possible. Very similar argument to the AFXDP. You get an open source driver, open source user tooling, but then some pass through on the commands that you're doing to a particular device. Coupling things from a given software stack, like the Netdev or the RDMA or anything along for the networking side of it, and its abstraction. Another part of it that hasn't necessarily been talked about in like Jason's patch sets, but something I'll show an example in a minute, but I think is really important for a lot of these device-specific tunables, and that's that we can have some self-documenting designs here. Another side effect of this, having some kind of a direct pass-through for some kind of vendor-specific kind of configurability, is there's no delay between a firmware release, some knob being able to be used by a customer. Right? With the channel, once the channel exists in a kernel, as soon as the firmware comes out, query it, see what it's got, boom, you can start using it. You don't have to wait for some kernel patch to be accepted into DevLink. DevLink makes its way into vendor distros. The distros makes its way out into products. Products finally say, oh, look, I can use this debugging now. Right? There's a long, many years that goes in between them. And some other domains like CXL and NVMe are having some similar needs, right? So it's not just a networking issue. So the pushback from the firmware control is, let's do everything in DevLink. And that's where it kind of overlaps with what I was getting at earlier, right? So we have a device that works across software stacks. And right now, I've asked the team to focus on debugging at a PCI device layer. We've got a Gen L that we can go tap the device, talk to it. It has the API. We dump all the resources. Okay. DevLink really could be that in some ways, but I don't believe if firmware control goes in, that suddenly DevLink stops getting any kind of standardized or commonality. Right? That was something that Linus said in the eBPF scheduler response as well. So it's kind of a straw man argument to say if an open channel goes in, all the other ones kind of fall by the wayside. Another one is that users in Linux ecosystem are better off with entry code that everyone can review and work. Another comment is made in that eBPF scheduler thread. Okay, so these out of tree modules, nobody wants them. And yeah, to manage compatibility across kernel versions, to telling customers go get it, vendors and Red Hat and all the distributions, they don't like these out of tree modules, right? But to put as much entry as possible is really the benefit here, right? So let's look at the existing DevLink. So again, the pushback was, well, let's just keep enhancing DevLink, add more tunables. So I ran DevLink dev param on the ConnectX 5 card that I have, and it dumps out a bunch of stuff on the screen. What do some of these things mean? When would I want to enable it? Right? What's the range of value? I don't know. I would be hunting and pecking, or worse, I have to go to the vendor website, try to find the documentation of what some driver specific tunable is supposed to do. Okay? So let's look at the Mellanox tool, for example, and some things that it has, which I do think, again, I'm not employed by NVIDIA, but you got to recognize things that are being done well. And that's kind of the trend that you want. So rather than having these, what are, for all intents and purposes, completely random tunables, DevLink parameter setting with no man page or anything else, you download the MST and Mellanox config tools, and you run this on a query. Okay, you get a dump of everything that exists on that particular device. Okay, arguably that's not really helpful either because I don't really have any help on it. But there's another command. That's an eye chart at this size. There's another command that comes in. It does do the self-documentation thing, right? So if I ask for the information about these lists of configuration options, I get the name of it, and then I get a nice description. I get some values there that say, when would you want to change this? What does this value do? What does that value do? Right? We need to be moving into this kind of a direction where we recognize that vendors have different solutions, different designs, and the concept of standardized tunables is a great ideal, but just not realistic. Because the devices differ so much. Okay, and with that, I guess kind of open it up. Like, what are thoughts and opinions about firmware control? And I really would want to keep this in the realistic ballpark and not some idealistic stances about something that's not going to ever truly happen. Because we do have a real need here.
Yeah. So as already expressed, my biggest concern would be the fact that, the vendors are just going to jump to, okay, we're going to throw all of our stuff in here and forget the standard interface. It's because they don't have to deal with any pushback as soon as they have this mechanism in terms of, oh, well, this is kind of like that, but I don't want to look at it. I'll just move forward. And so I can see that as being an easy go-to for, I don't want to have to bother with an upstream review for this. I'm just going to shove this here and then done.
Yeah, I don't agree. Vendors are already doing this, two options, and we do the standard thing. And who would want to review such a thing on the mailing list on DevLink when you can simply push it to a user space or plugin for a vendor? Why would you review this on the mailing list? Why would you bother even
I think it just answered itself, because usually most of this stuff is because customers have to scream bloody murder, get these kind of things when, okay, well, change this one variable. It's like, well, why was it we had to go through this tool and use this custom command to change this variable? What's it tuning? Mm-hmm. Oh, okay, well, here's the documentation for it. Now we've included it. It's like,
I never heard that.
I can give you more details in the SB NIC discussion in terms of why we're going with our own NIC.
Yeah, hi. I just wanted to say, like, I don't know any, like, I followed the thread on firmware control, but I just wanted to comment on the discussion that y'all were having in the front just now. Like, I've had this same exact problem. Like, I've tried to use like MLX config. Like, I think it's cool that like it works for you and like that, like you can use it on screen and you can show there's like documentation. Like I can barely get some of the tooling to work. Like, I think it's hard to Google like what some of these values actually mean to find answers to them, and like having to read and like a lot of times like the documentation description is like so incredibly poor, it just repeats the name of the variable as the explanation of what it is, and it's like I don't know what this means. And like that's why I think like using standard interfaces, in my opinion, like makes it a lot easier for me to understand like what are the things that I can change, how do they change, and like it sounds like what you're saying is like there's a documentation problem, and like I agree with you. There's a documentation problem.
Documentation problem. It's the fact that devices do different things, have different tunables, and people want to change them for different reasons. And it's impossible to have standard way of doing things. Just the GRO timers, what it means for Mellanox and what GRO timers mean for us. Completely different things. Zero way to standard.
Yeah, and this is not a documentation problem. I agree with you. Like, if I would ask you, which one do you prefer, such an output or the DevLink one, which has nothing, just the name of it? We need to improve the documentation. We will improve it. The question is, where do you want to see that document? In DevLink, because it will never happen, or download it from a...
That's the thing. Is somebody could patch DevLink to add the documentation, saying it's when the vendor says, yeah, it's never going to happen with DevLink. It's only in our tool. It's like, okay, hold on. Why isn't it going to happen in DevLink? Part of the issue is we see a lot of vendors are trailblazing in some new area, except for all three of them or four of them are doing it at the same time. They each have their own way of doing it. And that's for Broadcom. And so that's one of the big reasons why we're trying to push for, we want to have the same interface between, because otherwise as a user, it's really frustrating when it's like, okay, for whatever, they use this one, and for this one, I have to go collect this. Even the stats are problematic in that regard. Yeah. Where it's like each vendor has the stats they do their own different way, because ETH-S doesn't force them into any kind of specific area. So that's one of the things, that's another one where Kubo was dinging me for, even with FBNIC. It's like, okay, no. If it fits into the common Netdev stat, shove it into a common Netdev stat. I don't want to see duplication. ETH-S is only for the proprietary stuff, and it should be, you know, as minimal as possible.
Again, ETH-S shows you Netdev world.
So that's the case. Firmware control is only for vendor-specific stuff. It doesn't have to be in Netdev. But we don't have to put everything in Netdev, even if it was vendor-specific.
The problem is, though, there's nothing to prevent the vendor from then deciding, okay, all of this is specific. And so that's the thing, is that's where the fine line is.
I've got one. Okay. There's other questions in the back. Sorry.
So I look at this and see as a problem of visibility, right? So as you said, vendors do what they do. They don't open the firmware. They do different things and make different decisions. How do you standardize what they do? You can't standardize. Everybody's going to be adding features. So from that point of view, it seems like it's fundamentally unsolvable problem. But there's another part of this that you didn't touch upon. You didn't mention offload. Now, the offload may be a little bit different, because if we say vendor is going to support an offload, and we say it's a kernel offload, we actually do have a little bit of leverage there to say, you're going to offload some functionality. that offload has to match what the kernel does. And we have to have a way to verify that. That narrows the field for offload. So a lot of parameters obviously aren't related to that. But I think later on today, we're going to talk about things like checksum offload and GRO. Those are things that vendors should not be able to just do it and say, oh yeah, you'll be happy with it and we support it. We need a way to validate that they actually do match the functionality kernel. So I think there's one avenue here where validation is possible, and it is going to require visibility. And the saving thing here for offloads, at least, is going to be programmability in devices. That's where we break that firmware closure. Now we're saying, let the user program the devices for a lot of stuff. That is actually openness, and then we can validate the code. From that, you can generate documentation. So I think it's a little bit larger problem. I understand the immediate problems of simple parameters. But if you expand that,
the easiest way to show the differences. There's so many other more complicated.
Yeah, think about the long-term future of offloads, and the kernel bypass. I think is going to become a little bit of a red herring. It really, how much visibility does anyone not in the device, how much visibility do they actually have into what that device is doing? And fundamentally, for the kernel, becomes a simple question: can they actually trust that device does what they say they're doing?
Yep.
So it's a multi-pronged problem. I think we need an avenue here to go into more, get these guys more programmable, more visible.
So again, two comments. You said offloads. So GRO offload, again, that's Netdev concept. It's the networking stack that does.
Yeah, I think that's going to be the poster child of how we do an offload, because that combines everything.
Companies don't spend hundreds of millions of dollars to create the same thing that everyone else has. You create new devices because you're trying to solve problems in different ways with new features, new capabilities. By definition, it's not standard. It will take years. It could very well be, as I said on one of my responses, it could be a whim where the vendor failed. It could be the kick-ass feature, and all of a sudden every other vendor is like, yes, now we have a standard. But until then, just attempts at a solution to real problems that customers.
So one thing I'll point out, I don't know how many people saw the OCP networking feature requirement.
Yes.
It's an interesting read, but in a lot of cases, they have to punt and say, look, we can't explicitly say what all the requirements are for all of these features. And sometimes the punt is, just do what the kernel does and you'll be okay.
Right. And so that's where it became a Netdev-centric for what Google and Meta need for their data centers, not generic capabilities across multiple software systems. And then even just like the encapsulation aspects of it for header split got into I kept trying to go down some tangents, and it's just a big example how the OCP doc is good up to a point, right? Simple use cases and wanting hardware that does exactly what the Netdev stack does.
I have been adding many DevLink parameters, so I want to add and make sure that it's clear. DevLink has a good documentation, including man pages. Quite a lot of it is written by me. So lack of documentation is not an excuse to write firmware CTL.
So where do you put driver parameters?
Driver parameters are in DevLink params. We have function control, where a hypervisor wants to control a VF or a scalable function, is part of the DevLink port function to control. And it's well documented in man pages with examples. And if it's missing, I'm here to add more of them. Fundamental reason the firmware control exists, as the name suggests, as you said, is to control the firmware. What cannot be standardized using a DevLink for vendors, something that exists there. How I see it. If there is a feature in the firmware or a device that cannot be standardized because there are no 3 vendors who is supporting, how do you expose it? You wait for another 2 vendors for 3 years to bring that chip, which they also don't know how to compete with. So they put something firmware control exposed to the users to either debug or control of functionality that enables users like you explained. This is how I see it for control being used. At the same time, it's not a replacement to the dev link.
I would argue to some extent, if only one vendor has the feature, we need to probably wait. Because the fact is, for most users, at that point, if only one vendor has the feature, you're looking at vendor lock-in anyway. So most reasonable people won't look at that as, okay, I have to have that unless it is absolutely, a completely blowout feature. Most people will be like, okay, we'll just deal with the out-of-tree driver.
Right, so now you're mandating out-of-tree drivers.
Oh. Yeah,
I mean,
to some extent, that's the thing. Is from like a user's perspective, if it goes a couple of years, then maybe we can go ahead and standardize on that being the way to go forward.
Yeah.
But the problem is with a lot of this stuff, like LRO, for instance, we went through this whole thing where each vendor went off and did their own LRO, and it became a complete and total mess because we didn't push back on it. We just let everyone go ahead and roll their own LRO into the driver. All was full of bugs until we finally got to the point where, okay, no, hold off. We'll do hardware GRO and try to clean this up. And so I would argue letting the bleeding edge get in just because it's bleeding edge is just going to give us a lot of pain in the end. So it would make more sense to hold off and wait and see what the industry standardizes on rather than us immediately jumping to whatever the next new thing is just because it's the next new thing.
So then you start putting a hindrance on startups and smaller companies
that's
who are trying to solve
arguably they can go ahead and do
You're
the
saying
upstream.
those shouldn't be allowed to have upstream drivers because they're doing something innovative and different.
Well, yeah.
Ultimately,
if you want to use new shiny, you should have the pain of using new and shiny.
Right. I make everyone else feel the pain for it.
But there's a follow-on to that. What is new and shiny in 5-10 years becomes commodity. If you look at system on chips, they're all pretty much the same. Because what works gets standardized by everybody.
Yeah.
What doesn't gets thrown away.
Right.
We've got to try and be careful here that we don't actually make ourselves a mess in 5-10 years' time because everything's gone lots and lots of different ways. We actually need to force the vendors together when it gets to the system and chip world where we do have a lot of commonality.
I just say again, people are solving problems for a reason, right? These are real problems. And like we see people are just throwing money around. They're trying to.
Yeah, but they're throwing money around, know that some of it's going to fail. That's the way it works. What actually ends up in products 5-10 years later when it's commodity is just a small subset of that.
To me, that's not the, again, optimistic kind of view. That's the dreary view of you have to wait 10 years and let everything be not normalized and then, okay.
I was going to say, if nothing else, it's not 10 years time. We're probably looking at a year or two because usually the vendors all tend to release the same kind of features around that time to where they all kind of roll out with things generally around the same time. Just what we don't want to get is lock in on, okay, whoever's first gets to define what the interface looks like or just throw an interface in because then we have all of these interface kludges that end up out there that then they never roll back. That's
right.
The thing
so
is the problem where to some extent we're defining a user space interface here. You don't break user space. That's the big issue with this.
Yeah.
And so the problem is once it's in, locked in forever. And that's the problem. We can't just leave this wide open and say, okay, you want to push whatever you want to user space, go for it. That's basically the biggest reason for the pushback on this is once it's in user space, locked in forever.
So to the points that have been made, having an ability for new and shiny to be working immediately, vendor specific things that are standardized and common across hardware, it's natural for there to be a standard command for that, like the dev link. So you run the devlink command, runs the same on all the hosts. But it's not realistic to think that all the hardware is always going to have all the same features, right? Different vendors have different solutions for reasons and targeting different segments in the market. So we have to acknowledge that and allow a little bit of diversity.
So if I'm listening to the discussion, some of the things I hear is Alex's comments about about commoditization, right? So you're developing a kernel that's going to both support commoditization, like normalized commands, right? So for devlink, those things will settle over time. But what we've done now is we've got ourselves into a solution or a situation where we end up not having any room for the innovation stuff. So I feel like the kernel at some level needs to be able to account for experimental, right? We have this experimental config thing. I almost feel like the networking community could benefit from having the idea of some place where you can submit your cool new stuff, your hardware features, or some way of differentiating that this is not the settled API, right? I understand that we don't want to break user space. I think firmware control actually provides a valuable thing both to my company, Intel, right? And we want to be able to configure aspects of our hardware that are unique. And eliminating that from the kernel scope is a disservice to both Linux's customers and our customers, right? We're making it so that they can't use the hardware that they bought. And I think this speaks a little bit to some of Joe's stuff too, right? He's figured out that there's things that he wants to do that he can't do or he can't configure because it's not upstreamable because it wasn't commodity, right? So when you say it's commodity and that's required for everybody in commonization, it makes it impossible for innovation and moving forward.
So this guy back here's had his hand up for a while. And
okay. I think it's also an important thing to look at process of maturing. Like you can put something that is innovative that maybe only one device has in firmware control maybe. And then if more vendors come out with a similar feature, then you can do a devlink thing. And maybe it makes sense that I think the really important part is really do not want out of tree modules if at all possible. Like if it's just a pain. And it's especially a pain for, like I'm from IBM, the mainframe division for us, especially a pain. Not so common architecture.
Having to go everything out of tree for the modules, the vendor tools, etc. Like that just raises the bar so high just to do something basic is hard. The more stuff that's it's in tree where everyone gets to see it and other people can get ideas, right? And so that's how you start moving to the commonization of it by having. Let's get this guy back here. He's been patient. Hold on. Okay, let's go ahead. Jamal, let's let this guy go because he's been waiting patiently.
I wanted to say that as a developer, I'm pretty understand that having a common interfaces is like something that we want to achieve, but really not that possible with the variety of vendors and the needs because, well, if we are not providing the vendors a good way to describe what they are configuring, we end up with the situation when we have a kind of presentation of the Netdev when somebody is trying to solve the issue and you see on the screen that there is like a huge list of magic registers set it to magic values. And it's always like happening like this and you're not understanding what you're doing actually. And when you are hitting some kind of problem with the NIC, so you still trying to search the forum to ask the technical support, and only you get in response that, so here is a magic register, here's a magic value, so get this and this will solve your problem. Hell, I even don't understand what kind of a part of the firmware was changed there. So, and I think that the Mellanox config is like a step to the right direction. So at least it provides some kind of information. So some kind of interfaces that I at least can understand what is happening there. So I'm not saying that the documentation is ideal there. So, but it's still a step to the right direction. And when we try to commoditize the interfaces, it's always like you have some, for example, standardized firmware features like that are accessible, for example, from F-tool pivot config. So it is still configurable, but it's so when you're trying to solve your real problem with the NIC, so you still have a recipe from the vendor, you apply it, it actually doesn't work together with the commoditized interfaces, and it even crushes the kernel. So I would say that one of the best and cool things that we have with the Linux is we have some set of review at least and visibility. So, and if we have a firmware control that still have some options that like visible for everyone and review, and we will end up with some common places for the vendors, and it will be places standardizing.
But it's very rare to hear the words ideal in documentation in it. Who do you work for?
I'm from Duyck.
Okay. Yeah, we're doing fine on time, so I've expected this to be interesting.
So I have a question.
Yeah.
So I feel like the contention here is between vendors who want to innovate and standardization that leads to commoditization. So let's say that we have firmware control and one vendor adds some new cool feature, and then second vendor also adds a similar feature, but it does it in their own way. If they can do it through firmware control, what incentive is there for them to now sit down together, plus all the other vendors, and say, okay, let's hash out a standard. Let's hash out a way for us to work together, because incentives drive everything. So if you have a low friction, easy way to do what you want, what are the incentives for them to work together? Whereas on the other hand, if you don't have this way, the incentive for you to release this cool new feature is that you have to sit down with other people for the benefit of the community to work out a standard way of doing things. If that's removed, I think my concern is, and maybe other people also have a similar concern, is then people will just go off and, right, vendors will just go off and do their own things. Then there won't be that standardization step because it's too ideal, right? There has to be an incentive for that to happen because, as you say, your whole business has been driven by profit and money. So what are the incentives then after you've done it and you released it? Why would you then spend the effort together?
So I am new to the working for a hardware vendor, but there are a lot of people in this room who do work for hardware vendors. And how often do you call up your counterparts at the other company and say, hey, I've got this cool idea. I want to make sure we're doing it the same way.
Yeah, the incentive is in customers who want the standardization and one way of configuring separate feature like on all the devices they own in the data center. So it's there. I think the gap may be in the process of making sure that things that get standardized are moved to the standard way of doing things and removed from other parts so that they don't clash with others. And that's, I believe, I mean, if it's standard, yes, but if it's in like those custom interface, yeah, but
so forgive. You can argue that now, but the fact is, once it's in, first time you remove something, and somebody will cry bloody murder to Linus, and it'll be okay. Put it back. Don't break users. That's the thing. Is you can argue it's not a standard interface, but once you cause enough pain for the community, all of a sudden it'll become a standard interface.
eBPF found a big workaround for that. So did tracing. So I think there's some give. When there's UAPIs that have been defined, yes. Some things have been declared non-UAPIs, and so there does seem to be wiggle room.
Yeah, maybe.
So, so I just want to say, I mean, we've had some experience of that with Wi-Fi too. Added vendor control thing to the netlink so that vendors could innovate in their space effectively. And all it really did was push the problem somewhere else. So partially they did it non-upstream, partially it is upstream, but it really kind of pushed it all into the user space parts that then tries to paper over all the different bits. So, I mean, I don't want to be too pessimistic about it, right? But I guess what I'm saying is that like whatever you do, you can end up in a situation not ideal. In the end, it may not even matter.
Trying to solve a problem, trying to be optimistic about where it can go. Yeah, I mean, over time, complexity then builds up and unintended.
I mean, I think the incentive that David mentioned is a really important part. Where if you're at a company, what is your incentive to move to a standard? And I do think we need to have a little bit of flex to allow more experimental features in. And that's why I do like the idea, I forgot to mention this, that there is a kernel feature flag of experimental. And if we could get buy-in from Linus to say experimental means we can break you. And so vendors can add APIs they want, it's experimental, and as soon as the standard comes in, we rip it out.
I would love to see something like that, where you get a 2-3 year moratorium as you're developing a WIM.
Unlikely given past experience.
Well, yeah, the problem is as soon as you put it in experimental, it gets stripped out for like any commercial fetch. So it won't be included in Red Hat, whatever, and all of that would be considered experimental. Well, right. But see, that's the problem is you make it experimental and they'll just say, forget it.
Yeah, now we just defeated the whole point is Red Hat now has to deal with out-of-tree drivers for such and such hardware.
That's the thing is this is all meant to allow them to have these accesses in a secure kernel. And so it's like, okay, we want to have it secure, but at the same time, we want this open path between us and the device.
That's a nice lead into my question.
Yeah. Okay. So one more comment inside Andrew and then Saeed, and then we'll go to online.
Right. So thanks for that lead in. Do we have any security people here? And are they just going to knock this straight off because it isn't secure? Are we wasting our time because the security people will just immediately reject
Well,
it?
just to be clear, like this really has nothing to do with Netdev, and really we're discussing this in Netdev because Google came in and enacted, and then bringing the Netdev crowd in. It's being reviewed and evaluated on many mailing lists. So I have not seen a security person weigh in, but.
So yeah, we had security people involved in the design for MX5 connected devices. And yes, we have a security policy in the firmware. Firmware enforces that policy in a way to isolate user defined operations from the kernel operation. And it would guarantee that the memory integrity will never be problem.
Not a security person, so you couldn't try to convince me.
Yeah, I'm not trying. I'm just saying the security policies and design is there.
I know Jason is bringing this out on the mailing list, starting to, but I think that's a very important point.
If you're remote, unmute yourself if you want to speak.
Yeah, let's give a few minutes
so,
to let someone.
Anybody remote?
Last point. Kernel is not really providing any security per se. It's a get and set API to set some firmware control parameters. So how does a user API here really make a... My question is, how does a kernel is able to enforce a security by exposing a user API?
So as I understand it, Mellanox has or NVIDIA has the auth token. Somehow a user has acquired something that says, I'm allowed to talk to the device and do.
And the firmware makes sure it's not going to break any system.
Right. So it enables user space to program firmware. Right? Or for example, a comparison is with the DevLink. DevLink is not providing a security to get or set a parameter, just the channel where it's been. There is user can just set and get the value. He can feel it firmware CTL, probably he doesn't feel it, but security primitives in both is exactly same. Right?
Agreed.
Okay, so let's just give a pause and let anyone online wants to unmute.
So after the break, about 2:30, I guess. So we'll have a kind of continuation of this conversation, but it'll be more on the offload side. But there's a lot of overlap.
All right.
Very animated, Lance. I like that.
Are you seeing any comments, like people wanting to unmute?
Can we have, if you're remote, I mean, don't just keep yapping on the chat. You can talk as well. Nobody,
Yeah, I don't
have a
not
screen
logged
which you
in,
can see the
so
chat.
not seeing the chat.
Nobody remote? The last chance.
One.
But it's much more fun to just talk on the chat.
Hi, this is Sridhar
Okay, got
from Intel. Yeah, actually, today, even via DevLink, we have a device-specific parameters that we are supporting, right, in some of the drivers. Isn't that similar to what firmware control will provide? So today we are already supporting that. See, Mellanox supports some parameters and ICE driver supports some parameters that the other driver doesn't support. So how is this different going compared to the firmware control? If we allow DevLink driver specific. Yeah, David, you showed the list of parameters, right? The via DevLink param. So those are supported only by Mellanox. So today we already have a mechanism to do that.
Yeah, that's the point earlier was you have to get them. Maintainers have to agree that they're a relevant parameter worthy of being in the kernel. Yeah. Fact that they are built in, there's no man page, there's no documentation about what the values are. And
yeah, I think man pages and
the lack of documentation argument doesn't hold any water.
Sure.
And always require documentation as a part of the patch.
The infrastructure has to be updated to handle that, but sure. Okay, so let's say you fix the documentation side of it. Still hasn't addressed the fundamental thing, which is hardware-specific knobs that maintainers are deciding what's worthy and what's not.
Right. So the problem with firmware control is that we review patches. Is that what you're saying is the problem and why we need firmware controls? Because something might be reviewed and rejected?
Not. The point is, if you have a maintainer who is adamant RDMA not be discussed, but yet the device does RDMA thing, right? You have to have a way to be able to configure a device independent of a software. You have to be able to do a way to configure vendor-specific things in a device, period.
Right.
So again, if we want DevLink to be this device API, hey, it's going to have to be opened up and allowed RDMA concepts. And otherwise, it's Netdev thing that operates device layer.
Well, I think we've already had multiple discussions about the fact that we need to get out of the Netdev silo and start looking at other things.
Right.
I would argue at this point, yeah, extending DevLink to add more variables for these device-specific things would probably make more sense than having a means to bypass the review process and just allow the device to add whatever it wants, essentially.
What's the value of a device of a review process for a vendor-specific?
Okay, so for example, with firmware control, we just had a discussion. The Mellanox implementation went through and made sure all the security bits are there. Let's say I go ahead and decide to implement that for FBNIC, but I don't know, I don't need to bother with all that. I just want the knobs. So I go ahead and implement it and add oops, I'm going to write to random memory on the host knob just because I want to panic a system as one of my test cases.
So we can go down the pessimistic route of how things can be abused and misused, and we don't really make forward progress on solving problems for users and customers. We have to, there has to be some limits about what we're trying to do and limits on what we're going to what we're going to restrict people to do, right? And this is an attempt at solving a problem. And there are some pros and cons to it. there are some pros and cons to what exists.
Right. There's pros and cons regardless.
We have to move forward because what exists doesn't work.
That's debatable. Depends on what your definition of work.
That's what the last 45 minutes has been a debate. Fine. All right. I think we are at the top of the hour. So, is there another comment? Oh, yeah, Ed.
Yeah, I think that the tension between the innovation and commoditization, I think that by having it go through different programs and require review, effectively what we're saying is that the price of getting your new and shiny upstream is that you have to commoditize it yourself. You have to describe what it is, what it does, to some extent how it does it, to a level where someone else could not exactly copy it, but interoperate with it. And so you've invented this new shiny thing and you have to commoditize that yourself. And I know vendors often don't like doing that because they would rather have something that they could differentiate on. But I think essentially we require that price, and I think that's the way we should continue to do it.
So I would differentiate the new shiny features that processes use from new resource or new capability that needs a new API from device-specific tunables and configurables. And firmware control is really focused around velocity, not focused on letting you some new feature that the device has that there's no API for, you can just go bypass it. And now all the discussions has been around, we all have different parameters and different meaning for those parameters, and we need a way to be able to let someone customize for their workload these device-specific settings. That's been the focus, not some new whiz-bang shiny. All right.
Yeah. That's a recap. Yeah. The comment was that's why DevLink params exist.
Yeah. All right. Circle complete. Yep. Head is now following tail. Meeting adjourned. All right. Thank you all.
Oh, we wrap up. Just want to add, it's not just only about params, there's debuggability as well and predictability. I cannot predict what the next bug will be, so I'm going to push it in DevLink today. And it's like a cat and mouse issue where whenever every time you hit a new bug, oh, let's add it to DevLink, but it's too late because you'll never hit this bug again, probably, because you're smart enough now not to hit it. So every time you ask or you decide to put something in DevLink, most of the time it's too late.